In the last module, we focused on core data structures such as lists, tuples, dictionaries, and sets. In this module, we will shift our focus to how programs interact with real data and handle unexpected situations. We'll begin with file handling, where you will learn how to read from and write to files so your programs can store and retrieve information, an essential feature for applications like your to-do project. Next, we will explore exception handling, which enables your programs to handle errors gracefully instead of crashing. Finally, we will look at slicing, a powerful technique for working with sequences more efficiently. By the end of this module, you will be able to build more robust programs that manage data effectively and handle errors with confidence. Let's look at how we can write data to a file in Python. To work with files, we use the open function, which takes two main arguments, the file name and the mode. The mode determines how the file is accessed. The default mode is R, which is used for reading. The W mode is used for writing. It will create a new file if it doesn't exist, or overwrite the file if it already exists. The X mode is used to create a file, but it will raise an error if the file already exists. The A mode is used to append data to the end of an existing file. Understanding these modes is important because they control whether your data is preserved, replaced, or extended. This is a simple example of writing to a file in Python. First, we open the file using Open in Write mode. This will create the file if it doesn't exist, or overwrite it if it does. Next, we use the write method to add content to the file. Notice that each call writes exactly what you provide. Python does not automatically add a new line. Finally, we call close to properly close the file and ensure that all data is saved. Always remember, opening, writing, and closing are the three key steps when working with files. Even though we wrote line 1 and line 2 separately, the output shows them on the same line. This happens because the write function does not automatically add a new line character. It simply writes exactly what you provide. If we want each line to appear on a new line, we need to explicitly include \n at the end of each string. This is a common mistake, so always remember, Python will not format your output unless you tell it to. In the second example, we fix this by adding \n at the end of each string. This tells Python to move to a new line after writing each line. As a result, the output is now properly formatted, with each line appearing on its own line. This small detail makes a big difference when working with files, especially when readability matters. Now let's look at how to read data from a file. In this example, we first write 2 lines to a file using write mode, just as we saw before. Then, we reopen the same file in read mode using R. The read function reads the entire contents of the file as a single string, which we then print to the screen. Notice that the new line characters we added earlier are preserved, so each line appears on a separate line in the output. Reading from files allows your programs to retrieve stored data and use it for further processing. There is another way to read from a file using read lines. As before, we first write data to the file and then reopen it in read mode. The key difference is that read lines returns the contents as a list, with each line stored as a separate element. Notice that each line still includes the new line character \n at the end. This approach is useful when you want to process or iterate through each line individually, rather than working with the entire file as a single string. This slide shows how to delete a file in Python. To do this, you need to import the OS module, which provides functions for interacting with the operating system. Then, use the os.remove function and pass in the file name you want to delete. If the file exists, it will be removed from the system. Keep in mind that if the file does not exist, Python will raise an error. This is something we will handle using exception handling, which we will learn next. For now, to avoid errors when deleting a file, we can check whether the file exists first. In this example, we use os.path.exists to check if the file is present. If the file exists, we proceed to delete it using os.remove. Otherwise, we print a message indicating that the file does not exist. This approach helps prevent runtime errors and makes your program more robust. This example shows how to handle file-related errors using exception handling. We use a try block to attempt to remove the file. If the file exists, it will be deleted. If the file does not exist, Python raises a file not found error, which is then handled in the except block. Instead of crashing, the program prints a message. This is a more robust way to handle errors compared to manually checking conditions. We will come back to exception handling in more detail later. This example shows how exception handling can also be used when reading from a file. In the try block, the program attempts to open the file and read its contents. If the file exists, the contents are read and printed successfully. If the file does not exist, a file not found error is raised, and the except block handles it by printing a message instead of crashing the program. This is how we can safely handle file operations using exception handling, and we will explore this concept in more detail later. The with statement provides a cleaner and safer way to work with files. When you use with open, Python automatically closes the file for you once the block of code is finished. This means you do not need to explicitly call close, which helps prevent common mistakes such as forgetting to close a file. In this example, we open a file in write mode and write multiple lines to it. Once the with block ends, the file is automatically closed. This is the recommended approach when working with files in Python. This slide compares working with files with and without the with statement. In the first example, we manually open the file, write to it, and then explicitly call close. This works, but it relies on the programmer to remember to close the file. In the second example, we use the with statement. The file is automatically closed when the block ends, even if an error occurs. Both approaches achieve the same result, but using with is safer and more concise. For that reason, the with statement is the preferred approach when working with files in Python. In the next class, we will focus on exception handling in more detail. You have already seen a few examples of how exceptions can help prevent programs from crashing. Next time, we will dive deeper into how to properly use try, except, and other related constructs to build more reliable programs. This will allow you to handle errors more effectively and write more robust code.
Thank you for your attention today. This presentation was prepared by
준비.
with assistance from AI Technologies. I truly appreciate your engagement. See you in our next class.